In the vast expanse of our solar system, far beyond the familiar planets of our inner solar system, lies a realm of icy giants and their enigmatic moons. This distant region is home to some of the most intriguing and lesser-known celestial bodies, each with its own unique story and characteristics. Among these distant worlds, orbiting the ice giant Uranus, is a small, faint moon called Trinculo. This moon, though not as famous as some of its larger counterparts, holds a special place in the study of our solar system. Discovered in 2001, Trinculo is a member of a group of Uranian moons known as the irregular satellites, characterized by their distant, eccentric, and often retrograde orbits. These orbits suggest that Trinculo and its companions were not formed alongside Uranus, but were likely captured by the planet's gravity long after its formation. These small, icy bodies are believed to be captured objects, remnants from the early solar system that hold clues to the formation and evolution of planetary systems. Their irregular shapes and varied compositions provide a window into the past, offering insights into the conditions that prevailed in the early solar system. Trinculo, named after the jester in Shakespeare's The Tempest, is a captivating object for astronomers. Its name reflects the whimsical and unpredictable nature of its orbit and characteristics, much like the character it is named after. Its small size, irregular shape, and distant orbit make it a challenging target for observation, yet it holds the potential to reveal valuable information about the processes that shaped our solar system. Observing Trinculo requires advanced telescopic technology and precise calculations to track its movement against the backdrop of space. By studying Trinculo, scientists hope to gain insights into the formation of Uranus, the dynamics of planetary rings, and the distribution of icy bodies in the early solar system. Understanding these processes can help us piece together the history of our own planet and the broader mechanisms that govern planetary formation. The study of Trinculo is a testament to human curiosity and our relentless pursuit of knowledge. It exemplifies our desire to explore and understand even the most remote and seemingly insignificant objects in our solar system. Despite its diminutive size and distance from Earth, this tiny moon has captured the imagination of scientists and continues to inspire us to explore the far reaches of our cosmic neighborhood. Each discovery about Trinculo adds a piece to the puzzle of our solar system's history and evolution. As we delve deeper into the mysteries of Trinculo, we embark on a journey of discovery that promises to expand our understanding of the universe and our place within it. This journey is not just about uncovering the secrets of a distant moon, but also about pushing the boundaries of human knowledge and exploring the infinite possibilities that lie beyond our planet. The discovery of Trinculo was a testament to the power of modern astronomical techniques and the perseverance of the scientists involved. It was a journey that combined cutting-edge technology with the age-old human desire to explore the unknown. The story of Trinculo's discovery begins in the early 21st century, a time when our understanding of the solar system was rapidly expanding. In 2001, a team of astronomers led by Matthew J. Holman and J.J. Cavallars were using the 4-meter Blanco telescope at the Cerro Tololo Inter-American Observatory in Chile to conduct a survey of the outer solar system. This observatory, perched high in the Chilean Andes, provided an unparalleled view of the night sky, free from the light pollution that plagues many other observatories. Their primary goal was to search for distant objects beyond Pluto, but their observations also led to the discovery of several new moons orbiting Uranus. The vastness of space often yields unexpected treasures, and this survey was no exception. On August 13, 2001, the team captured a series of images of the region around Uranus. These images, taken over several hours, revealed a dynamic and ever-changing sky. As they analyzed the data, they noticed a faint object moving slowly against the background stars. This movement was subtle, almost imperceptible, but it was enough to catch the trained eyes of the astronomers. Further observations confirmed that the object was indeed in orbit around Uranus, and it was subsequently designated as S2001-U1. This designation marked the beginning of its journey into the annals of astronomical history. This marked the discovery of Trinculo, adding another member to the growing family of Uranian moons. Each new moon discovered around Uranus provides valuable insights into the planet's history and the processes that shaped its current state. The discovery of Trinculo was not a serendipitous event. It was the result of a carefully planned observation campaign and the use of advanced image processing techniques. The team had meticulously planned their observations, knowing that the faintest of objects could hold the most significant discoveries. It was the result of a carefully planned observation campaign and the use of advanced image processing techniques. The team used a technique called shift and stack, where multiple images are digitally shifted to compensate for the motion of the target object and then stacked together. This method, though time-consuming, was crucial in detecting faint objects that would otherwise be lost in the noise. The team used a technique called shift and stack, where multiple images are digitally shifted to compensate for the motion of the target object and then stacked together. This enhances the signal from faint objects, making them easier to detect against the noise. The shift and stack technique is a powerful tool in the astronomer's arsenal, allowing them to peer deeper into the cosmos than ever before. This enhances the signal from faint objects, making them easier to detect against the noise. The difference between the raw and processed images was striking, revealing details that were previously hidden. The discovery of Trinculo highlights the importance of continued exploration of our solar system. Each new discovery adds a piece to the puzzle, helping us to understand the complex and dynamic nature of our cosmic neighborhood. Even in the 21st century, with all our technological advancements, there are still new worlds to be discovered, each with its own story to tell. The universe is vast and full of mysteries, and our quest to uncover them is far from over. These discoveries not only expand our knowledge of the universe, but also raise new questions, driving further research and pushing the boundaries of our understanding. Each new finding is a stepping stone, leading us closer to answering the fundamental questions about our place in the cosmos. The journey to find Trinculo is a reminder of the endless possibilities that lie ahead. As we continue to explore the depths of space, who knows what other secrets we will uncover? The adventure is just beginning. Located approximately 8.5 million kilometers from Uranus, Trinculo is a dim and distant world. This small moon orbits Uranus at a significant distance, making it one of the more remote members of the Uranian system. Its small size makes it a challenging object to study, even with powerful telescopes. The faint light it reflects is barely detectable, requiring advanced technology and techniques to observe it. Based on observations of its brightness and assuming a typical albedo or reflectivity for outer solar system objects, astronomers have been able to make educated guesses about its characteristics. From these observations, they estimate Trinculo's diameter to be around 18 kilometers. This tiny size places it among the smaller irregular moons of Uranus, which are numerous and varied. This makes it one of the smaller irregular moons of Uranus. These moons are often captured objects, meaning they were not formed in place, but were instead gravitationally captured by Uranus at some point in the past. Due to its distance and faintness, little is known about Trinculo's surface composition and geology. The limited data we have comes from indirect observations and comparisons with similar objects. However, based on its location in the outer solar system and its likely origin as a captured object, scientists have some educated guesses about its makeup. They believe that Trinculo is composed primarily of a mixture of rock and ice. This composition is typical for objects in the outer solar system, where temperatures are low enough for ice to remain stable. Its surface is likely to be heavily cratered, bearing the scars of billions of years of impacts from smaller objects in the outer solar system. These craters can tell us a lot about the history of the Moon and the environment it has existed in. Observations of Trinculo's light curve, which measures its brightness over time, provide additional clues about its nature. By studying these variations, astronomers can infer details about its shape and rotation. These observations suggest that it has an irregular shape and rotates on its axis with a period of several hours. This rapid rotation is not uncommon for small, irregularly shaped celestial bodies. This is not uncommon for small celestial bodies, which lack the gravitational forces to pull themselves into a spherical shape. Instead, they remain irregular, shaped by their history of collisions and gravitational interactions. Despite its diminutive size and the challenges in observing it, Trinculo holds valuable clues to the formation and evolution of the Uranian system. Each piece of data we gather helps to build a more complete picture of this distant moon. Trinculo's composition, surface features, and orbital characteristics can provide insights into the conditions that existed in the early solar system. By studying these aspects, scientists can learn more about the processes that shaped the outer solar system. Its composition, surface features, and orbital characteristics can provide insights into the conditions that existed in the early solar system. These clues are invaluable for understanding the broader context of planetary formation and the processes that led to the formation of Uranus and its moons. By piecing together the history of moons like Trinculo, we can gain a deeper understanding of the dynamic and complex history of our solar system.